All right, cool. It is there. Okay, we don't do this. No. Oh. Oh. Toggle. Do 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 do. Hey Trap. Well, you perform with Blue Shark in field. Oh, I hope you practice a little bit with Termux and stuff like that. Otherwise, I think you will find it a little bit hard. But I hope you succeed. You know, in your. Let's see. Can I do this? Yeah, here we go. That worked. I hope you succeed, Trap. See you again. Oop. Do 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 do. So, I am being bored, and that's why I'm gonna live stream a little bit and see if I can code some stuff. Figuring shit out. Should I look at that now? No. Here. This is what I'm supposed to look at. What am I? What have I been doing? I've been doing quite a lot of stuff. Besides doing all the wireless shit show, which is awesome to get to talk to Alcantara and Dark Matter and awesome people. I have been looking into making the low frequency detection, auto detections, a little bit better. Let's see, I have to do this in order to see this. So if we take the Proxmark has a traces folder. In the traces folder you have tons of copies of different encodings, and if you take it you can data load it and then set debug mode 0. We can do let's search one new. It will detect it, everything like that, but it should have actually continued to do this. Here we go with a C. With an unknown signal, I want to see this a little bit better. Now I need to remove some stuff again from the code, because otherwise it will be a little bit much of garbage. I do things. Back there, thank you. Right. Whoop. Make J. Can you see this? Can you see the? Is it big enough? I think it is. I'm not sure, but I think it. And this wasn't going to be like that. You need to see. Let's do this. No, let's do this. Maybe a little bit. Nah, maybe like that. I don't know. Is that better? Yeah. Same. So if you do this, load that up again, and then we continue here. And this is what I've been looking at. This is normally that it identifies that trace for what it is. Plot. Yeah, you can see it. So, which is cool. So you see a nice plot like that. This is a new little scroll bar down here, which helps you go fast back and front. I like it. Good addition. Whoa. I need to turn off some notifications here. Whoa. I don't have Discord on right now, so don't expect it to answer anything. expect me to answer anything. All right, let's see. All right. Cool. I swear I didn't release a video. I'm actually releasing a live stream, so let's do that. The thing is, when I do, you can have the data raw. Back to this one, data raw. You can see the detection. Oh, what's this? Okay, clear. Easy to do this here. So you get the decoded things, and if you do data print X, you can see that the hexadecimal from that. You can also invert that by adding an I, and I think I also made reverse. Strip hex, no, reverse is not there yet. Okay, cool. So when I do this for unknown signal, let's say data load dumps Iceman LF unknown LF BB. There you go. So, oops, no. And if I look at that, it looks like a raw. Yeah, I added this. I want to do this. And I wanted to do this much better. One of the results from we making the demodulation or the LF signal much longer is that I also increased the numbers of binary strings. Before this was limited to 512. I think it's limited to 2048, 2K now. So I wanted to do that. When you analyze a signal, low frequency signals, you do this autocorrelations, and if it finds an autocorrelation, a repeating pattern in it, if you consider to be one sample is, you need to know how many samples there is for a bit. So if you know the clock, you need to know the clock for the signal, and if that is detected or analyzed, or you get that out first, you can just divide the number of samples by 8 bits, and of course the clock is bits, it's 32. Clock means that is 32 samples for 1 bit, and you want to divide it to bytes, so you divide it with 8 again, and then you get, what this repeating pattern should be related to, and in this case it would be related to 8 bytes of repeating hexadecimal data, and that would fit into 2 blocks of T5577. Now what I really want to do, that was the beginning of this, fixing this up. I also added the NRC, but it's also a lot of false positives here, but I also want to add this. I want to see, the repeating blocks, hex bytes. So the reason why it says 8 bytes there is if you do data raw and data plot. It's there. Okay, it looks like that. But if you do data auto correlate, window 4000. Okay, yeah, nothing happens. And if you do -J, it will change this out. So you just go out and zoom out a little bit. You see a repeating pattern. So between these tops is the amount of samples, and that was 2074. If you zoom in, I can take this one there, and I'll take that one there, and it's about 2081. You see it down there. Oops, no. Move over there again. Yeah, this one goes over there. So 2071, 2001. So this is the value when I get the number of samples repeating in this, and that's what's used in this. And then to detect the clock, when I do G like that, I change detect clock command now. So if you do this, you get a suggestion that which one it could be. So it suggests that with ASK32, so you can get out the clock. And we can get the autocorrelation sample out now. That's why we make these predictions in how many hex bytes that's fair. With that said, that's sad. No. I go this, I go this. Alright, cool. What's that? Bring it more up. Oop, it's gone. Boom. All there. Alright, cool. Good. And done. So that would be. Can I do that? Can I do browser? Yeah, I can. That's good. So if you look at the clock, for instance, like this, if you know the clock, figure shit out, because in here is all the samples that's needed. Let's go for Siggy. Here. So with that, we have when we clock the number of samples, and then we do search -1 yeah. We get that. Now I want to know the bytes of a hex. That's my issue right now. If I got all this blocks out here, got the correlation, number of bytes. Question is, how do I find a... Hi Mike Dobbs, hello Blade. Well, thanks for all you do in the community. Well, I'm happy you like it and glad that you appreciate it, and thank you for your kind words. Cheers to you. So, what do I need to do if I want the hex text, the repeating patterns of hex? I think I would have to be in here. Now to correlate, I don't need that because we changed that. I do need this. Find repeating here is where I was. This is where we were before. Find repeating hex patterns. All right, let's see. So if I have a find all, oh, none. Let's change that to int. Let's change that to int instead. Beard is gone. Yeah, it is. I'm sorry for that. Let's see if I get it back. The kids were like, "You look different," and then it was, "You look much younger out." So I think I'm aiming for the younger, handsomeness again. Actually, there we go. I think my biggest issue with this is needle and a haystack. So I have an hex string. Let's see. What do I have? Print demo buffer. Thank you. Print hex. Yes. So I got a hex array here, right? Can I get repeating patterns out of there? Print and look. Whoops. Let me know if my typing is too much in the microphone, by the way. Let's print hex in a row. Thank you. Would be hex, and that would be length. Number of bits. Okay. Let's go for this one first, and then bits t, and then down string bits maybe. Hope it's not. Shouldn't be. Should it? Size max be offset buffer. Yep. And then we do a print and log normal info. Okay, let's see. Yeah, you have to do that. Or do I quit make J? No, it doesn't like that at all. Why? Oh, because I have this. PM3 in arg warg. Hex is data. What did you get? It got shards. Okay. Add two columns to you. Int 80. Let's go for that one. PM3. Have a great Christmas. You too, man. Have a great Christmas. Have a lovely, jolly holiday. Alright, print x. Alright, here we go. That's completely false. Okay, that's not what I wanted. Let's do this. Copy, quit, this data wrong am, and then this data print x. That's what I want to have in my command. Cool. And then I go over there. Let's see, it's not hex there because I think it's just hex like this. Well, J. Alright, cool. Cool. Okay. I basically repeated that stuff. Good. So let's remove that. And then we're gonna see for find hex patterns. What am I gonna look for? Length. Ooh. Sterling. Maybe. Will give me what? Sterling will give me 2 shards per byte. Give me if it's 40 bytes, should give me about 80 plus 0 termination. What are you gonna do for Christmas, everybody? That's the question, isn't it? I can do this. Oh wow, you don't see the code, that's why. Okay, let's do this. Both windows up as one, so I wonder if I can do that. What code? Yeah. Let's see. Log bits, not length. Size T, and that's for needle. Return, oh no, return. Success, just skip this. Does it work? Yeah, it did. Cool. So we got 295 shards. Right. Oh, makes kind of sense, but I also see that this is something I need to take care of. Okay. Alright. This. Yeah. Yeah. Okay, cool. Doing that instead, it's easier. No, we're not going to do that that way. We're going to do this. I'm going to do that. I'm going to do Oh, have you seen all the wireless shit shows that's out there? Got a suggestion for listening. I need some coding music. What is it? Boris Brecha? Boris. Oh, Spotify installed on his computer. Piotr, you sound like you from somewhere east. I hope you're doing well. No, Boris Brecha. Boris Brecha. Popular song. A mix from them? No? This is Boris Brecha, yeah. Well. Okay, some good shit. Okay, cool. That's some good shit. That's some good shit. If you don't know what music, you should go for Boris Brecha on Spotify. It's good coding music if you like that stuff. Alright, so what do I need to do now? I need to do a needle. So the idea is we have a repeating hex, correct? We have a repeating hex, and I want to see a repeating needle as a block of bytes inside of there. So if I find 8 bytes, I want to look for 8 bytes of hex in there, which is 16 shards. So I want to see that. That's my needle, and I want to see where it is, where it starts. Okay, let's see. So my needle is that. I need to have a size of a needle. So I can make it generic so it finds all kind of repeating things, or I could have four shards. No, I want 8 shards. No, what was it? I want T55 block is 4 bytes. So I want 8 shards. Okay. 4 bytes. That's what I want. And if I repeat looking at things, it's not half, but max is length, which I get in, minus minimum minus 1, because end of end of thing max. Do you want to do this? Do you really want to do that? Max. What do you want to do actually? Not half, but I want to go to length minus needle length. Alright, because I want to do. So this is what I want to do. Let's see, let's just try to do this like this. So I want to do, let's see, let's take some hex here. Boop. That's a little bit too far, maybe. Let's do that. Let's go out. I want to do this one. So what I want to do is I want to take 1, 2, 3, 4, 5, 6, 4. 1, 2, 3, 4. That's or the length of a repeating block. See, they know it here. You see how it repeats already? So that's what I basically want to do. I want to have this where I find repeating blocks like this. But then what I noticed when I try to do it is that if I have a flexible needle, it doesn't match up. So let's see, I want to do that. That means I have to limit this. I have to limit it. And this one repeats directly from the beginning, right? Yeah. How many has? This is 16 shards, okay. So basically, the needle would be, let's call that N. 4, 6, 8. That would be my needle the first time, and then the next time would be one step. I would compare like a sliding window algorithm. I would do that to see where it overlaps. And from there, I want to find. This is a highly repeating hex string, so that would of course be a little bit annoying to do. Let's go 0.8. Here we go. 22. Yeah, here. That would be a little bit. So one more. Okay. So I have a hex string in chars. I want to have a needle, and I want to start up position 0 plus 1. Not minimum. Plus 1. So this goes for maximum. Oh, that's size. I have to do size. Size. I hope you like the Proxmox project though, still after all these years. This would be max minimum. Yes, we can't overgo that one. So that's the repeating one. So what happens then? If it matches, this is, you know, does this match? Okay, let's just first I have to do I need to make a needle, or can I just repeat it in? Two different ways to do it. Either copy a needle to a needle, or I run 2 loops on input string and compare with input string. Let's see, I have a needle here, so yes. Let's start with that. Let's start with that. Maybe a better solution is copy needle, destination source is, to call it HS, and it's minimum. That's the needle length. It's not minimum, it's needle length. And length. That means there's a 0 in there, right? Okay, so it's 0 base. This is 0. All right, cool. So I have it in needle now. Okay. As for the sake of it, let's print the needle. Alright, so this is will loop, because otherwise it doesn't matter. Hey King, how are you doing? Okay, let's see, one more door out. So if it matches, first char matches, start comparing the rest of the needle. We can do num compare, but I can just do my own X needle length. So x plus I, yeah, that's the offset. And well, yeah, wait, this is two different ones. Yeah, okay. X, this is some other code. We have to start over. Let's start over. Let's see, that's the outer loop, that's the inner loop that goes to there. If HS I, that's the starting point. I'll start at 1. Length. And the other one has to be in here, right? So if no, it's not. Yeah. Equal needle I. No. Or I and 0. Hi MX. How you doing? You all doing fine? You all having holidays? No? Maybe? Let's see. Too dark, maybe. Maybe it was too dark, yeah. Better? Yeah, doubtful. Battery's off already? Maybe it is, I don't know. There we go. Maybe better. Alright, cool. Wrong mouse. Let's go for this one. Here we go. Oh, needle. Cheers, everybody in the stream. If you're allowed to drink. I plus 1. No, we're not going to do that. We're going to do actually we can just do 0 and less than middle length. All right. If HS I plus J not equal needle I J needle J, and if it doesn't match, we just break out of here. Okay, cool. What do we do if this is in the end then? Let's see, I have to have some bool. Raise false. Let's raise false. Oh. That doesn't matter, does it? What am I want to do? String comparing in C sucks. Actually, I'm not going to do this. I'm just going to do. I'm too bored for this. I'm going to do this. Mem compare H I comma needle comma end length if yay it matches. Cool. Let's just do analog match here, and then we're gonna do HSI, and we're gonna do dot star, right? And it's gonna be length. Basically, so this would, is that what I want to do? Let's see, dot max, and we'll print a match, and I'm going to print it at index. The index is I, and that's says U. So this will be I. All right, make J. Makes it. Okay, it doesn't like that. Cool. Do you know what we can do? Make a reference. Does it do this? Oh, got that. And then I blew there. Oh, that should fit it. Why on earth was that? I wonder if that may happen. Okay. Alright, let's do this. Okay. How on earth did we break this one? Demodulation versus this, it's not even close. And that's a string length. Why on earth? 16 and 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's here, right? Oh, okay, so that makes sense. Do, 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 do. Okay, so you can do this instead. Plus I. Run GDP, run bookmark. There's no frames, okay. I am. G, right? J. So what's up, MX, the King, and Piotr, and Blade? What is going on? All right, didn't like that. Okay, screw you. Screw you. Back here again. Commerce. Why is that? Is that too long now? And length is. Oh, we've come up the. X smashing. Let's just do this one. What is this? Mac. Need exists. Alright. What? Sage does not exist? Yes. How can that smash the stack? One from Max. And we already set that one, so I don't need to do that. Is it this that doesn't match up? That one doesn't match up? No. Should be position, yeah. That's how you do it, so this is it. Most likely that one, no? I'm stupid. There we go. Look, match, 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 match. All right. Okay, cool. Let's see. AM. Index. Yeah, so this is the odd ones, right? You see that it fits the minimum. But let's. Problem you see here is if I save this. It's repeated, right? So, and if I do this, this pattern is repeated until there. So this is the smallest one. Yeah, okay, let's see. Okay, we're getting there. Let's get back to that one. Let's see, I don't need print this one because I already have it, thank you. Okay, a little bit better. Let's see. Donation for Streamlabs, man. Thank you so much. Cheers to that. Appreciate it. I don't think I see stuff like that. I'm so sorry, I'm not very good at all this streaming things, but yeah. Cheers. So this is repeating, but it's also repeating until there, and that is repeating until there, and this one repeats all that. So it's, and then I have two long repeating blocks. What I do want to have here is not the same repeating blocks, so I need to keep track of, this is what I want to have. I don't want that. You see the difference, because this one contains okay, let's do this one. Let's go back. All right, let's see. This is what I have. All right, let's see. Let's see. God, get away from me. Let's start there. What I do need to do is a running needle, right? So I need to do this, and I need to do that. I need to run the needle. This is it. Yeah, first zeroed out, copy HS plus I. And I have to do this from 0. Alright, so this is a running needle one, correct? Yeah, but I need an hour other one. I need to size T, oops. I need another one, size T, x equals to 8, x is smaller than 7, let's see, 7 blocks times 8 shards, and x increases with, how much do we increase this one? How much will we increase it? We'll increase it by 8 every time, right? Well, it will give us blocks of 4 because that's what we're interested in. Right. And that would be x. And then I need to do this because that will change. I can't compare longer out. And then we do this, because that's x again. And that's that, alright? Alright, let's see. Make it. What, compiled? Hey, look at that. Cool. Right, cool. Cool. Oh, yes, because that's the offset. You know, no offsets. Exactly. So it does that over and over and over. Let's go for that one. I'll move that one because that one working. Let's do this. Alright, cool. So this is the largest one. Yeah, this you can ignore because that's index 0. Yeah, this is the negative. So this is, you know, block. Start with that block and it matches there because we are now suddenly comparing from. We are starting there, but we are doing HS plus 1 for the needle. Should be less matches a little bit at least. It's no matching. That was interesting. Why not? Oh, it fits, doesn't it? Hazardous voltage. I don't know. This is nasty though. This is not a good thing to have. Cheers. Thank you for the nice warm word, and I hope you enjoy the community. I do hope you appreciate it all. I think we have a kind of nice community. It's kind of polite and high level, so I'm kind of I'm proud of the community. I can say that looking in your face. Yes, I am proud of the community. You're doing well. And I'm amazed by see all these advances people do, and people giving the efforts to it, and it warms my heart. With that said, back to the code window. Yeah, that's the problem here. If you want to listen to the same music, you just go to Spotify and join into This is Boris Brecher. Good shit. Good shit. Oh well, while I'm doing this, you can tell me, let me know in the chat what kind of NFC or RFID hacking you'll be doing. I'm always curious to hear feedback. Tell me your greatest war story. It can be anything. MX cracking a transport card using hard nested. 700 seconds? Damn. Which card was it? Which transport system? So running 2 or running 1 and 2. What I'm after here is actually, if you look like this, because I got some matches, right? So many matches, but the repeating pattern is actually between here. And if we go for something inky, if you look this one here, it's about 16 shards, which then adds up to the idea. Let's go up here, up here. Yeah, you see, it's always 16 shards. Oh god damn, it's too many. Okay, let's lessen this one to 3. Sorry. Let's do this. Yep. Okay, let's see. Let's do this first. No, okay. All right. Question is to see whether or not. Yes. You see, between there and there is 16. And even if I go back to when I only have, God, 8, it's still thing here. 92 to this is 16. So what it does tell me this is here. It tells me that it repeats on 16, and that is exactly what I want. That would give me the longest repeating pattern without repeating itself. You feel me? An obnoxious thing to do. I'll write to an encrypted second announcement so I can sniff and grumpy. Yeah. One of these days in Christmas I will try and sit and look at static nested nonsense. Have an idea how to solve it. It's always figuring shit out that takes the time, and once you, well, you know, the insights into how you feel that you're on the right path, the solution is quite easy. But before that, it's kind of annoying. But right now, it's like 2 steps, 3 steps: collecting the data, calculate some shit, and then from there execute MF key 32. So yeah, that's a 3-step solution to that one. Actually, static nonsense. But yeah, it's not that hard. But here it doesn't repeat itself. So even if I do this, the string length, I don't need to do all this 16. You see it? Because I can figure out already here. How about I just, if I don't do that, I don't even think I need to do this, do I? I don't think I need to do this. Let's say x is then 8, right? And then take that away. I only need to do it once. And that is 8. I now need to keep track of previous run. This is what I try to do now, is keeping track of when it compares. Running 1. Can't have that one there. because it is there. So here we go. Could be running 2. I don't know. That's the first time. Now I need to know the distance between J. Yes. Okay. Let's do like this. Distance. It's J minus running 1. Is that you, right? No. Okay. Romanian one, my fair classic. Ah. Yeah, look, 16, I got it. I got all that stuff, look. Up there. Here's distant 8, so that's interesting, oh, okay. How did you figure out the what do you call it? Did you figure out the key generation algo for the transport card instead? Because that would be easier for MX. First charm matches. Yes. I don't want to do that. Do I want to do that? No, I don't want to do that. I don't want to do that. I don't want to do anything. What do I want to do? Oh. That's music. Trentemöller. Kiko. Does it still do things? I need some other music. What do I need? Miss Monique, is that what I need? Yeah, okay. Let's see. Miss Monique, if you ever heard, she's kind of good. Let's see. Oh, Romanian. By the way, you Romanian guys. Oh, that's Electra. You have that as well. Side notes. Side notes. File. Oops. Very clear signal. Look at that one. Beautiful. Mm-hmm. 16 repeating bytes, 4 blocks. Maybe not that now because I had this stuff there, so that's a little bit annoying. Here. That looks exactly what that looks like. Data number X666 X 66666. Yeah. Yeah. It's not that hard as you think it is. People who think the Electra signal is hard to understand. It's very simple. And you wonder why is it simple? First of all, let me just remove this stuff. Let me remove some stuff here because it's just annoying. Yeah, remove some stuff. And we do that. So that's how it looks like. No, thank you. Okay. This is why. One is highly repetitive, and those 555s. You know what that means, right? You know what 555 means. Same as AAA. Bonus points for one who can tell me what is 555 significant to in terms of low frequency analyzing. And bonus points so you can tell me why AAA is it as well. Come on, someone. No? Nobody? 5555s is, if you look at it, it decodes to binary 010101. AAA decodes to 101010. So both A and 5 can be used to see as a standard pattern. However, that pattern is very related to something called Manchester encoding. Let me go here and show you this. Manchester encoding, yes. So high, low, high, low, high, low, high, low. Starts with low on this one here. Oh, I think this is off because it shouldn't start with low. So you see 0, 1, 0, 1, 0, 1, 0, 1 means that actually, now this is wrong. It should be, I would say, it should be like this. To be a 1. So you just strip away, basically, so I have, oops, let me see here, let me be bigger, 0, 1, 0, 1. All right, that's 5, 5, 5 in hex, well, 5 in hex. Now you strip away that to 1, 1, you remove a 0, so you keep the both zeros, doesn't matter which one you take of it, and one of them is just the inverted value, and that's what it becomes. So that's a clear indication that it's a Manchester encoding. So for you Electra, for people who doesn't understand why that low frequency tag doesn't work so well, or decoding for it yet, is because there's a big part of Manchester encoded data there that's not treated well. So when you do the normal EM41 or X demod on that one, it will fail. We need to do set debug mode 2. And we do this, and you see what it says. It says parity fails. And now you're going to know, Iceman, what are you talking about? Why is it failing? Well, let's do like this. Let me copy some of its values. And let me show you what that mean in a brand new thing here. I'm just gonna squeeze them up a little bit. So remember this here, up here says it's a start preamble 111111 9 bits of ones for an EM41 4100. Electra uses that, so if you align this up with those start bits, and we didn't, doop, doop. No, that's not it. Boop, and I'm going to do it here. So if you line those up here, you see what those two repeating pattern is, right? So this is a start ample, boink. And if you go back here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you go down here, you see this is 10th column of 5 bytes. So you go here, and then you go 1, 2, 3, 4, 5. You do this. Well, this is what EM tries to do. And oops, it fails because of the new presence of this sledge here of data, right? It's a sledge here of Manchester encoded zeros. Then you check with parity. Boop. You go over here, look at this. So according to this one here, it is even bit of parity. It means that the number of ones totally here should add up to an even number. So this is okay. And this is wrong, and this one is right. And this one is wrong, and this one is right, and this one is right. So this signal is not the best. Have I taken it right? Wait. Yeah, it's my bad. Okay, let's go back again. I should have calculated before I did this crap. Sorry. Let's see, I assumed this, but it's not. It could be, this is the problem. It could be either that, or it could be 1, 2, 3, 4, 5, 6, 9. What is that? That's 9. Okay. So now we do this, and if we do a little bit this fast, this is the number of ones here is even, so it's okay. and here's the number of ones is even. All right, so you do this all the way down until you get to the sledge of and here's the sledge of Manchester again. All right, so okay, and 1, 2, that's 2, 2, 2, 4, 2, 2, 0, 2, 4, 2, 4. So the parity is okay, so this is a valid EM tag, but the decoding that you're all having a problem with, I was supposed to give it to the devs, the Flipper devs, but I know that it's not that they know this shit. It's, you know, I mean, they took all the code from Proxmox. You don't expect them to know how to actually do it. That's fair. Hi, Levis Groff. I'm happy to see you here. What I'm just trying to say for those Electra people who are having an issue with it, it's not that a problem. The problem is that the repeating pattern is, it has a repeating pattern of 128, which is an indication of long bytes. As a proper EM encoding in that repeating pattern. This is the proper data, and then comes the sledge of Manchester encoded stuff, which is what Manchester encoding. This is the sledge that messes up everything else, because normally on the other Electras which we saw, I don't have one of those, but you know, the real ones, this might be on, you know, I don't know why, but this data here, this is why it fails. So you just need to have an exception for that one, and the Flipper devs can now implement Electra and claim that they did it. Smiles. It's not that hard if you know what to do, but if you copy code, it's very hard. So this is Electra. How to solve I think it's with K, isn't it? Electra failed. Demodulation. And we don't have this. We don't have that. We don't have that in the Proxmox thing, do we? We have demod, but we don't have that. You can just call it with a binary, and it decodes it. Wouldn't that be cool? It wouldn't it? It would be really cool if we can take this. Let's see. What's this? What's it? 1, 2, 3, 6, 8, 9, 10. Yeah. If I took this, went somewhere there, and gave it as an input to demo. Yeah, let's do that. Just for the fucking lols of it. Let's do that. Let's go here. Let's just let's call something else. Let's do that. Let's manually add that --bin bin. Let's do this for the pure lols of it, okay? It's nothing. I actually try to boop, optional, and we do this, boop, boop, and we do this, boop. 6. Oh, 129. Let's do that. Let's go for 129. Boop. 129, thank you. If bin length what does that do? Huh. Bin. No, bin. Fine, thank you. Next, thank you. Null, okay, yeah, okay, cool, so it becomes 0. If bin like that, let's do our own little call to something. And what we want to do is not decode like that, we just want to do, we want to skip this part. That's printing, we don't want to do that, we want to do, let's skip that part, let's do this, we do for int, and we're going to do sk em for next decode bin, and we do, I'm going to do move his stuff here. Yes, because we got all bits already there. Let's go this. Here we go. And when we do t bits, size to size. No, we're not gonna demo off this one because that would be stupid. We'll do that, and then we'll do sk. So, nope. Static. Thank you. And then where is my? Oh, I want that as a return code. Boring. I don't want verbose. You don't want that as well? High low. Okay. I have to do this. Okay. Okay. Wait. Why am I doing this? It doesn't do anything. It doesn't copy it. Ah, okay. I can take it away. I don't need to do this. That's too funny. Because it does this. It doesn't do that. It does this. Okay, go there. Framework search. Do this. Do that one away. I'm gonna do this. Let's see. Yeah. It's start index is no start index because we get a raw thing. High and low is without numbers. We not. Okay, just add that one there then. Blah blah blah. Static, blah 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 blah. I don't need to do that. What am I trying to do here? I don't need to do that as well either. I need to do, what do I need to do? I need to do this and that call. Because they take this there. Yes. Okay. One more time. What I do need to do is I want to take this. I need to take that and make a static version. Binary decode. That's what I need to do. Oh, thank you. And then I will get this one here. Boop. I will have this one there, and I will have an int 3 bits, and then I will have what is size 2, okay, and I will have a size 2 size, let's call it size. I'll do that. An index, do I repeat that? This is what I return. Printing that one. And do this. Modify all that stuff there. And we're sending in size. Bits, we know what it is. We are sending low. We're sending high. We're sending verbose. Bits is still this one, and that is not bits, it's bits. Bum bum bum, and then set demod plot, and then we ret. No success. Boop. And decode. There you go. What is index? Do we use index here for anything else than there? We do use index. Okay. All right, let's do this. And I'm sending that one and that one. New command. Yes and no. I'm just right now. I'm just in the. I got a feeling of trying to improve a binary input for LF EM4100. Well, that's not really what I wanted to do, but I'm doing it anyway. Okay, cool. All right, cool. Well, all right, cool. That's this one. Let's see if I can do this now. Verbose is true. Say true. And high, low. Bits is binary, right? Bin, yes, bin. And then size was bin length. Okay, let's go for index. I don't think I need that. All right, so that would work there. All right. We'll do it a little bit faster. We do it up here instead of doing it here. All right, cool. All right, let's see. So we go in there, do this, does this. All right. Here does this. All right, let's see. Make J. Defined but not used. Interesting. Static but never defined. What? Ah, sorry about that. Should be that one. Oh. Okay. Okay. Why didn't you tell me there's a missing thing here? All right, let's see. Can I take this code here? Help dash bin. I'll set debug 2. All right, cool. Samples is not enough. Okay. Let's see. Okay. Bin. What is it in bin? Okay. Okay. And it doesn't like that. Ramsat, reverse party. No. Demo buff. Yeah, okay. So we're sending him that, but it doesn't want to have that. We need to do yeah, we need to do that. What to convert it to? That's one of that. We'll have a hex thing. We'll have a. Wants to make that to a bin array, bin string. To bin array or bytes? Let's see. That would be bin. Bytes. What's that? 16. Okay, let's see. Bytes. Target length is bytes. And then we send in bytes instead. I'm sending in no, doesn't like that. Ah. What do you want then? Char. Const char. Const char. Oh. Okay. Demod LF EM 4 Alex demod bits. Or bits. Why doesn't this work then? Bin string to bytes. Okay. Hello, SH Sue? Well, I'm trying to figure out. Nah, I thought of, you know, if when you do LF4X demod, it would be interesting to be able to give it a binary string instead of having to load a file. So if I do data load file traces LFEM, yes, there we go. If I do this, if I load that file, I can do now EM41 demodulation, demod. And it would be nice if I could just send in binary string. When I've done all this decoding myself and I want to send, oh, I got this string of binary, I want to call this command with a binary instead, like this, and I wanted to demodulate it. And this is right now my little issue. It doesn't want to do it that way, so it's not bytes bits, byte strings. All right, bin array. Oh, yeah. So that's just an improvement in order to show how you should be able to test. Okay, what do we want? You want target, char source. More length would be bin length and bin length. Boop. So I can do that. It's just for testing purposes, and I'm just trying to do this, and I want to see how it looks like. Now it doesn't want to do that, of course. But excellent. No, thank you. That's what I'm trying to do right now. It's nothing special with it. So size of bytes. What does this one do again? Blah blah blah. It converts it. Blah blah blah. Okay, cool. Good. It was just a part of showing people how to actually decode and analyze T-fifth funds. Okay, so it's almost there. Right now it's just confusing here. Because there was this small dialogue on the Discord forum about how the Romanian electric or Electra cards doesn't demodulate, so it's a new version of it. And basically what you look at, if you decode, okay, let's do that one more for you newbies, for you people who doesn't seen it yet. But if I load one of those earlier dumps, Electra, Electra PM3, and I do data raw, data plot, you can see it's nice signal, so you can determine a lot of things with that. But we know it's ask modulation. So what you do is you take this data here and copy it to a file like this, and then you start trying to align it up. And if you look at here, it doesn't align up yet, but there it aligns up, and you do this. So you see those two lines up, that's the repeating pattern. And if we go into here, you see this is the EM41 protocol, and it starts with 9 ones. Go back to here, and then we go start looking here to align up a lot of ones. And then I go counting 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you start doing this. And you will see this is exactly what I've done up there. So you just slice it up with 5. Why you do 5 is because you have 5 bits and a parity bit. 5 bits and a parity bit, and you have 10 blocks of that. So if you do that whole way down there, it's gonna look like this. And then you calculate the number of ones, and it should be an even parity bit here. And even means that the number of ones should be even. So you just count 4, then it's okay. 2 and the 0 there, it's okay, and all of them matches up. And this is the leftover thing in the end of it, why all the Electra demodulation fails right now, both for the Flipper devs and in the Proxmox code and now. And I said the reason for that is because this data here is 010101, which is a typical indication is a part of Manchester decoding. So the repeating pattern that comes up that we do and send in is this, while we just want to send in this part. So I said, wouldn't it be nice to be able to just copy that one and put it in here in LFEM for 10x demod with like binary, and it would demodulate that binary string for you. Wouldn't it be nice? Well, that was the plan. So right now I'm trying to see why the interesting, nice little conversions here. It doesn't want to have bytes. I noticed that this thing here, it doesn't want bytes. What do you want then? The different process bits to bytes. What is it then that you have here? What's in your bits? What's in your bits? And that's what I'm trying to do here. Here's the bits. I'm seeing what's in there. And I can't for the love of it figure out what's in the bits. So I'm just gonna do a simple loop instead. Simple. So much simpler that way. X is smaller than 64. All right. This is just printf bits. Seems like doesn't want to do what I want to do, so printf blah 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 blah, and I do a this unsigned it, and I do this. I call it input and do this and do that, and now we do make and see what kind of input that's going on when I do this. No, not that one. This one. The input is this. So it is a binary array. And this should have converted to it. This should have become a binary array. Now I'm trying to figure out why this bin array does not do what I think it want to do. Target source length. We got that, and we got that. And that's going to be this. It's not bits, it's R. Thank you. Make. Well, it makes sense here, doesn't it? It's too small. 129 one, okay. Nobody told me. Okay, so we have this. Not enough samples. Well, that's interesting. What the hell is this? Okay, is as sending in two small values. Okay. So what am I sending in? Okay. You made? Do you think I made it now? Preamble not found. Cool. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, because it looks for a 0. Parity failed, which is one step closer. That's good. Alright, cool. Now send in this. Oh, the parity should fail. No, it shouldn't fail. Why did parity fail here? Ah, yeah. It's because you want to remove stuff. You want to remove this. And we already done that. No, haven't. So yeah. So what are you all guys doing on Christmas? Or whatever you do. So, okay, let's see here. 10. 10. Alright, let's see. Okay, header. Okay. No. Let's 4, 5. 10. Whoops. Oh, no. Here we go. It's okay. 11, 12, 13. So it's a little bit longer here. And so it should be only 10, right? And that would be, so column parity bits calculates from here to there, so it just goes, oops, these ones, all right? So in that sense, let's see, that would be, how many ones is it here? 1, 2, 3, 4, 5, 6, 7, 8, yes. 2, is 0, and then it's 2 and 0, and then it's 1. So these 3 numbers there are the extra numbers. Okay, let's remove those extras, and that would be 1, 2, 3, 4. That's that one. And that's that one, and then it's that one. It's this one. Okay. Let's try that one then. And 1, 1, 0. Yeah. Interesting. Mm-hmm. Mm-hmm. Calc. Right, let's see. You know hexadecimal by heart. All right, let's see. What do we have? We have 9. We have 5, 1, 9. A 8, 9, 0. That's B. That's D. All right, and that's this one here. That's this. What's that? Copy. That's 7. Okay, interesting. 7, 7. Well, that's one. B, C. Okay. That's parity only, so mass makes sense. And we're coming to row. Oh, what do you have here? Alright, so what's that in hex then? What's that? Data hex. What's that in decimal? That would be this. Okay. Hey, thanks for the gift, man. Hey, Funky Monk. Daxi. Sisek. I don't know if I'm doing good work. I'm just doing some work. And, well, cheers to you all. Merry Christmas or Happy Holidays. So, that would be the binary on that. But we still didn't make it work. Well, this one tells us the parity didn't work. I don't like that. Nobody likes that. Why didn't parity work? Remove parity. The problem is this file here is annoying file because it's used on both from device side and client side. So printing here is annoying. Let's see. If ndef on device. Oh, nope. On device and if print that would be what I want to print. I want to print size. I want to print size. Preamble size. What would be ZU? Size ZU. Well, let's see if that works. I don't think it works. It's that one always complains. No, or not. Looks like I'm. 4. Preamble found, not samples. It has to return -6, right? That's down here. Why didn't you print it? Make J. Are you sure that you did that? Nope. Oh. And oh. Well, now we know something about pointers. $64. All right, that makes sense. That's perfect. So that's perfect. So it's not. It's should be perfectly a short, valid short. Should have returned this, but it goes in here. It's long now. It's 55 because it's really not long, is it? Let's see. Beer length. Billing. All right. No. What do you don't like here? Is long is long. It's not long. It should have got there. But what's wrong here? Sometimes some things just doesn't. No. Okay, the one who does that should be ashamed of themselves. Trust me when I say that. Whoever names their variables like that should be ashamed. And do not go into git blame now and see that it was me who actually changed that. I change my coding styles, every year. I like parentheses nowadays, or angle brackets, or sometimes you do camel case. 55, cool. So it's a short one. This is perfect. Look. So why do you say that it doesn't work? Well, it's short. Right, let's see. Valid short should be correct. And valid short is what? Valid short is a bool. Okay. We can do that. Valid short and then bit count. Bit count. Return. Whoa. Size T. Okay, size T. Right, cool. No. Cheers, everybody. Debug and Bitcoin 44 valid short. No, why is not a valid short? 1. That's interesting. Why it should be in here? What happened here? Why is this skip? True. This is Dojox Phillips code. So we did parity test for that column and we added that column. Yes, and that makes sense because that's normal. And it's 55, so that's perfect. So we're doing that. Parity nibbles. Yes, 1, 2, 3. And we're looking at that one. What is it that we're not? What is it that I'm missing here? We have that 0 based 11. That's correct. Okay, so now I need to do this. Is long. Bool. Okay, so I don't have to do that. That's bool is long. Is well, it's not. It shouldn't be long. It should be short. So yeah, this is true. So let's do this. As long as false, that's correct. Skip column part is false. Wait, one more time. So it's no, it's this. Why is that one? Okay. Data load. This is EM. No. EM. Thank you. I don't know. I don't know. I don't know what's going here. Why is that on row 55? Yes, okay, so let's go back to explain this. This here is a static number, that's why. So this here is a stop bit. It's not a parity. So the parity for this, for this one goes that way. That's the parity here, and this one is there, and this one is there, and this one is there. And this is not that one. So this is just a stop bit. It should always be 0. So this row, you know, you don't do a row parity. You do column, 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 but you don't do column on that one. So you see this 0 here is absolutely correct, because that is the stop bit. So that's okay. And let's see from this was 1, 2, 3, 4, 5, 6, 7, 8. So that's okay. That's okay. And then it was 1, 2. That's okay. And then there's 1, 1, and 2. That is okay. And then there's a 1, 2, 3, 4, 5, 6, 7, 8. And that's okay. So this is a correct one. And it's on index 10. 0 days, so it's 11. I'm going in here. Parts, yeah, okay. Bit length 11. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Makes sense. Makes perfect sense. What am I missing? We are missing this. Why? Okay, let's just go here and let's look at this one. I'm gonna do this. I'm gonna take that data. I'm gonna do that data. I'm gonna do data load. I'm gonna data raw am, and I'm gonna look at this here. That's the data from that one, and I'm gonna look manually. What on earth is going on? And this is another one. All right. Let's see. It's not there, and it's not there. And we remember we try to align this. So look here. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Cool. 1, 2, 3, 4, 5. All right, so that's 0. So stop bit. Okay. Okay. Yes, that's okay. And that's one is also okay. Yes, even. Okay, so all of them are correct, which is completely correct, right? Now we look here. Now we look here for a column parity, which we seem to somehow mess up. 1, 2, 3, 4, 0. So that is okay. I'm gonna go here. 1, 1, 2, 3, 4. That's okay. 1, 2, 3, 4, 5, 6, and that's okay. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Well, that's okay. So it's all okay. And what is that? F. No. Oh, 3, 6, 8, 5, 6, 8. Ooh, what's that one? B. So the value here is then whoop. 5 bytes. Well, that's the number. And that number in hex is num hex, and that's that. Okay. Is it correct with that number? 0368. Yeah, that matches that number. So this seems to be wrong. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2. 1, 2, 8. It's okay. This number is okay. This number is okay. This doesn't make any sense. Parity skip column. Okay. Okay. Cool. Row parity. Wow, am I blind? 4, 4, 2, 2, 2, 2, 2, 2, 2. No, that's okay. No. This does not make sense. Wait. Bits. Bit count. Let me guess. Back. Nothing to do with that one. Let's see, we're going in here. Yeah, okay, let's see. If and if on the device and if it. Mm-hmm. Zero. And that is correct. Okay. Let's print it out. Let's print it. Let's print it. We're gonna print Word, comma, no, Word. It's not here. Word skip is a bool. Signed. NFC kilo. Any values you try to look for? Well, you want to squeeze out as much as possible to make that EMP pulse or the EMP to be strong enough. So if you're too small, you end up doing... Alright, let's see. Ziggy visible. Okay, let's go for Ziggy like that one. Yeah, so if you have this, then you end up with an EMP thing like the Chip Whisperer or Chip Shouter, and that's too weak. That will not, you know, that pulse that this generates is not strong enough. So you would need to make one that's, you know, make a big ass thing. So if you look at one of those devices, I think, I think there is a fantastic pictures or RFID pictures. Yes, here we go. I think there is a EMP. Here we go. There you go. So that's the internals, how it looks like. You know, it has 3 big ass capacitors. So yeah, like this. You know, see that site? Oh yeah. It's Dojok's RFID pics. If you're not following that one, you should. There you go, that one. I don't know if you think it makes sense, but I hope it makes sense to you guys. But you know, you go there and look at it, and you'll be happier. Oh, You're 450. I want to. You can make one for me as well. That was too funny. Okay, back to the coding again. Back to the coding. That doesn't make sense, does it? Wow. Doesn't add up. Okay. I want to look at this even more. What on earth is this? What is that? Okay, let's parity word. Yeah, let's go for that one then. What is the parity word? Parity word is you. Okay. All right. Wow, look, 15. Should be B. What on earth is this? Word, yes. Bit. Word plus bit, start index. Oh, oh. Ah, okay. Okay. Okay, so start index. Should have been this. But somehow start index is not start index. Okay. What is start index one? Feels like I'm doing this over and over and over. Size u start index. Oh, sorry. See you. No. Yes, here you go. There you go. Start index 10. Is that correct? Yes. No. Yes. So parity, row parity. So basically what this does, it's, so you say words, it means basically you want to do, you know, this. That's what it tries to add up. That's what it does here in this loop here. 0 to 4, and so it does this. And it adds up here by shifting it, so it takes all of those individual bits and swap it into this word. Which is then very fun, because let's do that in hex. Let's do that in hex. 0-based hex, okay, let's do that in 0-based hex. All right, F. So if we look at this, it should be, what is that? That's not F. Well, if you only take the parity bits, yes. Does it only take the parity bits? No. It take the bits, shifts it in. Yeah, no. So it shifts it in. Yeah, you should get, should have gotten, should have got word at least. What am I not sending in here? Okay, it's obvious it's something that I'm missing here. Obviously something I'm missing here. Let's do that. Let's do this in word, okay. Yeah, 0. What is offsets? Yes. Yeah, so it's word plus start index, okay. Going into old code is it's equally funny every time. So starting next 10. 4. 10. None of this makes sense. What on earth am I missing here in this code? I'm missing something. I'm missing something. What is it that I'm missing? Because this code also does another thing. It also removes the parity bits, so it's you know, all of his bits will be removed. This pack it all together, and he reuses the old array. So once it's iterated through it, it's, you know, it's perma changed. Perma change. But okay, let's go old fashioned. Let's go old fashioned. Let's go really, really old fashioned. Let's do this. Let's give it to me. Give it to me. Give it to me. Give me old style. Oh, give me old style. F G Q F G. Quit. Thank you. Make old styled printf debugging. All right. All right. Cool. Let's see. That's not correct. That's not either correct. Okay, it's not correct because it's an offset of 1. This is this one. So we're looking at this data. So it's misses by 1. And I have this. So it means my call, I got it. I got it. It means that my call in preamble search here, in there, gives me zeros. So how about I do, let's see, if I do another 0 then, does that become right now? No, you see here, still off. Off by 1. Preamble search, is it off by 1? Is that what it is? False. Okay. I'm calling here. All right. Found 1. Yeah. Makes sense. So that's where you are. And here's the preamble. Starting next 10. And still 10. Yeah, okay, cool. All right, cool. So it goes in here. Mem compare. Okay. This gives us a start index again. That is... Y is off by 1 here. How come it's correct otherwise? Is it correct because we're getting a 2? Is it correct because it's 2? Is it? Please let me know. This one. Is it this one? Yeah, because it finds 2 and divides it off 44, and it maps up. So if we only have 1, is there a bug? Is there a bug in here? In this one? In this? If I only find 1, index is this. How can it be wrong? Starts at 0. Starts at 0. Index found at 0, right? Plus 10. You feeling it? You feeling it? It only finds 1 preamble and it gives me 0. And when I add 10, the length of it, which is not correct because I need to do, it's not that one. Should be, this is index. If it's 2, it's correct because it converts over to index again. But if it's small, wow, how do I know if it's... Okay, let's go like this. Let's do this. Here we go. That's the Electra tag. The Electra tag that we were trying to manually do. Because we're sending in an index and not a count. Okay. And if I do loading this will fail now. Because offset is wrong. Yep. There's a logic bug there. Awesome. 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 There's a logic bug. Alright. We're gonna handle that one in a good way. How the fuck is that gonna be a good way? Okay, it's a logic bug. Well, obviously, is if start index is, if size is small, Could be like, you know, yeah. Cheers, everybody. Kentaro, I know you're watching. And I know if you've been naughty or nice. And I'm keeping a list. Or I'm gonna find you. Now I can't do that well. Is that Liam Nielsen who does that? You've been not running again, El Contoro. Parity, yeah. When you got in Paxton, yeah. We have Paxton, don't we? Think about decoders there, isn't it? And the same here. No, where was that? Paxton. Here you go, Paxton. Where's your Paxton ring? But no, maybe you want to do it in high tag. So here you mean this one. Looks more nasty. Looks very much more nasty. I'm not gonna go in there. I'm going away from there again. Sorry. No. So not doing it. I'm going back to my stupid off by one bug. And most stupid is that I'm just like trying to figure out a good way to detect it. So if I have a short, now if I give him a binary, you know, once you coded it, this is why I always wanted to things being coded. People always wanted to do this manually, and I'm like, fuck you, I'm not going to do that. It takes too much time. You know, I want to have this, you know, I want the tool to solve it for me if I'm going to repeatedly doing this stuff. And figuring shit out takes time, and finding bugs takes time. And not always a bug exists, you know, that's a unit test. We don't have unit tests in that sense in this here, you know. You figure shit out when you try to do it in a different way. It's like adding as a binary string, and it makes you realize, hold on, there is a damn pattern. It's a lot of trial and error. I'm so sorry for that, but yeah. So tell me, El Cantaro, are you missing my voice? Tell us a story, by the way. El Cantaro is full of shit. Full of stories. Great stories. awesome stories. I mean, if he ever wants to, you know, someone who makes, you know, the NFC kill, Darcy or Daki or whatever, you know, Alcantara would most likely tell you how to build it into a, you know, a little teddy bear, and, you know, you just present the teddy bear left and right, and you know, you have this enormous EMP. Wasn't that this old Kodak small one time with his flash charges that people made an EMP with? That would be cool to see if that worked. You have to adapt the coil though. Well, that made a massive boom. Now what I'm stuck in now is not identified what this problem is this here. Is that if you only have one preamble in a string, so let's make my hypothesis. Let's go for that. Okay, let's go. Let's go. Let's fix the old code. Oops, no. There we go. Let's fix the old code. That's the old code, and my hypothesis is data load f dumps electric lf electric pm3 data raw. So my hypothesis is the following. If I take this much of things, and I do this, and I do new this, and I do this, how long is that? 256. All right, cool. And I do lf em41x demod bin, and I do this. That's too long. Fuck it. All right, like this. All right, 9. All right, I have to adapt the length of input. Yeah, let's take 512. All right, let's go for make. All right, so no, it's okay. Data. My hypothesis went to crappers. Starting index 11. 0, 1. Yes, and it finds this. 11. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That should have worked. Why didn't that one work? That should have worked. No issues sending us one to Sweden. Depends on the postal services. I mean, it's not sending it. It's not an issue at all. It's just Post Nord. Sometimes, you know, our postal services has a tendency to be assholes. I don't think we coil in that matter makes that much things. It's the it's the capacitors, and then apparently what makes the EMP thing is the gap. So you need to make sure, you know. Okay. You know how the gap is. You know what triggers the EMP is. You have a coil and capacitors, and then there's a gap, and when you shorten it, then if the gap is too far or whatever, so that is what generates the pulse when cross bridges over those. So I mean, if you can The cables can't melt. But 450 volts, I don't think that's how much amps do you actually put into that. So nah, I think you should be fine. I think, you know, it's 24 gauge, or what do you call this, AG24 or what you call it in the States. I don't know. Oh, slot jammers, you did that shit. That's cool, actually. I've heard about those, but, you know, and kind of cool when you see it on there. Oh yeah, the repeating pattern is longer than 128, and then you have a Manchester decoding problem, so that's why it's still that problem, so it doesn't matter. It doesn't matter. I need to know why this is. How do I do this for one? How do I do this for one? How do I do this for one? You're welcome. Okay. This is bizarre. How did this happen? Why did this happen all of a sudden? This didn't make sense. $128, okay. No. Now you're just mean. This is just mean to me now. Okay. You just mean. This shouldn't work. Okay. This shouldn't work at all. But okay, let's see. I'm taking it. If it's all of a sudden starts to work again. Yeah, okay. I don't think so, but okay, make. Alright. So we have data load. Data load, test this again. Traces lf80a/em. Here lf-em4x demod. Right, cool. And then we take binary and we take no, what? Yeah, this one. Okay. All right. Okay. Let's see. Thank you. No. But it worked just a moment ago. Okay. I don't need to print that one anymore. It's not this one, it's that one. Mm-hmm. I'm not gonna say anything anymore. I'm not gonna say anything anymore, but I know what's the problem. I have no idea how to work it through right now. So the question is then the following. All right, cool. The question is the following. Woo. Here. Preamble search. How on earth can that fit? How on earth can that fit? How on earth can that fit? Fit. How on earth can that fit? Where? How about make this one smaller. There you go. Okay. How about one? Thank you. I want to see why on earth this actually doesn't work. First we go for data load. Data load. Demod, thank you. All right, so Let's make some valid load demo 2. Okay, great. Index at 34 and length at 44. All right, cool. How does that transform to from index and a starting point? I still don't get that part. It's hex. Let's go for this. Data print x1 should be printed, should be the same. Copy. I'll still get it how that one goes out. Line 54 index. No, I'm going to take this value instead. Doesn't make sense. Here we go. Let's see. How can this be 34? But it still points on a 0. Doesn't fucking make sense. Alright, let's increase the music and not think anymore. Cheers to everybody. For all of you viewers again, if you managed to listen into this craziness anyway, feel free to tell me about your war stories, your best stories. What are you doing, and whatever you want to do with RFID hacking? Let me know. Besides you, El Cantaro, because you just want to listen to my sexy voice. Oh, V6, cool. Hacking is good for you. Hacking is good for your brain, man. It's hack the damn system. Hack the planet, man. Hack the system. Hack everything. See the systems around you in society everywhere. Hack it. It's very healthy for you. You know, even in academia, see the systems, see the problems, you know, whatever in your research area, you know, go for it. But whatever you do, and this is a tip from a coach, from Iceman himself, saying, don't run your own crypto algorithm when you implement an NFC tag. It's bound to be dragons. You join a bug bounty program, one of those, you know, for Bug Crowd or Hacker One or Integrity or whatever it's called, and and then then you're gonna think it's relatively few bugs in the NFC world, in the RFID world. Oh man, web-based. Whomever decided about, you know, what everything should be web-based, open up a whole heap of shite. Pure shite. So my problem right now is the preamble search is it's dependent everywhere. This is a function that's used everywhere in the whole damn project for everything. So if I change this one here to adapt, because what it does now, it only finds one and it does this, which is correct. However, how this gets a different size, but it still uses the start index from there. If I change this, since it's used everywhere, we're gonna have an issue, because this returns an index point, which is correct. And then we go back to here. Problem is here we use that index and we add a size of this preamble, which is 10, which is when you go from a size to an index. So it isn't an index. If it's 0 and you add 10, it gives an offset by 1. So that's the issue. And I can't change preamble search function because it is used everywhere. So if I search for it, you can see here it's everywhere it's used. So you don't want to fiddle with that one. You know, I might hard code something in here. You know, an ugly hack. We all loves hacks, but maybe not that much. We can do this, which is a nasty hack. Now that would, as you see, sort out a whole heap of bugs, right? Or it will give me this. And it doesn't work here because you need the a preamble, which is with 0. But we do love nasty hacks, don't we? Who don't know? Let me know in the comments. Let me know what you think about hacks in the code. Crappy code. This is a code smell. This, if you ever worked with software development, this, when you see things like this is when you go like, oh, nope, I'm not committing this. I'm not merging this in my code base, And then some manager comes along and says, why isn't that fixed? Like, because the solution looks like crap. I don't care. I want to have it now. Okay, you got it. And then it lays like that for years. And problem here, I don't think it's an acceptable thing, this one. Now we have to debug the second one, which is, even if we just do this, well, now we have to go back here. So even you've done that, you still have this error. And this is because what we're calling this one is way longer than be a length. It tries to do parity checks on that heap of Manchester encoded data. Remember I talked about that up here? All right. What is Manchester encoded data? Let me do like this. Boink. Yep. So we have until, was it here? No, where? What was it? 1110, 11110 here or somewhere, all right? Yeah, there. It tries to calculate the parity bits on these, yeah, these ones. So until here, where it's okay, but here is extra data. It tries to calculate all that stuff as well. So this one still matches up, so it's even. So this is correct, but the first time is false is of course here, because it doesn't make any sense, This adds up, and this one fails, because if it's one there, this is where it fails there. And that has nothing to do with parity. That has everything to do with before that. All right, let's go there and decode. All right. Mem compare bits size equals 0, 0. Stupid. Oh, event 8. How many are we? 48. It's about 20. Okay, let's do that. Let's do something nasty. We like that. So what we do have is like we just want to cut that shit off. Let's see what we can call this function now by way in here. I wonder if that works. It shouldn't work, of course, but no. What do? Wait. Yeah, because this is not. Long and I give up. It's oh, look at that. Gentle Kiwi has published the whole project for his this one or Ziggy Camp. Ziggy. For his this project, he actually published it. So yeah. If you want to make your own, go for it. Wow. Yeah, I know you're happy with it. I know you do it for learning and you're very good to do it. Yes, I know. Do that. Gentle Cube is such a good guy. I mean, he does always fun things, and I love that guy. Every time I meet that guy, I have a good time. It's like, you know, meeting El Cantoro and celebrate his birthday every time. You know, it's same thing there. Just fun. Hey, thanks, Ted. Thanks for your shout out, man, and thanks for your whoops. Let's do that. Let's see. Let's do this. And we do, oops, the next one. Bop, bop, bop. Find it everywhere, but let's do this one. Friday 21st EMP. That's fucking awesome. I love that. Thanks, Ted, anyway. It was a side note. Thank you for your super chat fee. That's very nice of you. So all those there's a cloner in Canada. I don't know who it is, whose name it is, but if you're ever watching this, feel free to reach out to me. I know I dissed you quite hard for your closing down the open source project, but what you do with iClass is impressive. So, you know, don't feel ashamed. I have no hard feelings. Anyway, I thought that was kind of cool. Let's do this again and remove that shit. Oh. I think it's like one of those things that, you know, Gentle Kiwi does, you know, just for the fun of it. He just wants to learn. And I so appreciate that. And thank you, Vlad. Thank you so much for your donation on PayPal. That was very kind of you. Much appreciated. No, I like that. I like Kiwi in that sense. He's not afraid to learn. Did we didn't make that talk yet. I'm gonna make I want to do a conference talk at one of the big ones where, you know, we went through and multiple things of actually reversing, figuring out the firmware on the SIM module that's built into RDV4, Model 4 has a little sim model in there but didn't handle things. I mean, Sentinel, who made the firmware first, he made it in assembly, so no problem with that. It's an amazing guy, but he was like wanted to help me out when I want to have a SAM functionality to the Proxmark, because that one really uses all the different finer things of ISO 7816-T0 protocol. So Kiwi was like encouraging and doing things, and we were like tracing, and we're doing all that shit on it, and sniffing out the data traffics to figure out what's going wrong and not going wrong. And then he started a project, actually, it's like, okay, we can't do this in assembly. How about we just make a whole new project in C? So he started up that project, and then he had to go for a business trip, and then I added up and changed the things that I needed to do, and it made it work. And it's like developing with that kind of attitude with someone. It's find yourself people like that around you when you do things. An island, if you're on an island, it's gonna be lonely for you. It's more like it's like the high fidelity film, with an island. It's better to find some good people around you that pushes your limits a little bit. And I'm very fortunate to be able to talk to some really amazing people in the community. Really amazing. Yeah. With that said, no, I'm not going to CCC, the Congress, this year, and I really would love to have met some of you, and especially Carlo Mayer, and talk to you about a whole heap of things. But I'm going to go chaperoning my kids' skiing trip. So yeah, that's going to be me and 10 teenagers instead of going to CCC. And no, I'm not going to ShmooCon either. ShmooCon is a very fun conference. It's a smaller one, and I liked it. Same with SaneCon, I like that one as well. However, it's also, if you come from abroad, it's a long flight, it's expensive, and the hotel expensive, and all that stuff. It's such a small one, Shmoo, so you need to know people there. Another one says like, oh, just to know someone. It's not true. It's really group wise. And even if I'm fortunate to know people now, I would think if you go to Shmoo the first time, it's such a tight nested group thing there that's going to be harder for you. But it's definitely worth getting in and knowing them, because the people there are the ones you're going to see everywhere. It's the same hardcore clique. I don't know if it's like 500 people or 1,000 people. That's the hardcore clique that's everywhere. You see them on DEF CON, Black Hats everywhere, on Shmoo Saint. You see them everywhere in the world. You see them on Congress, you see them on the camps, you see them on EMV party, you see them everywhere. And that's for dedicated people. Those are the ones that you need to get in touch with. Yeah. Back to code. I'm still listening to Miss Monique. If you don't do, you should go on just some good beats on there. Some progressive trance. Yeah. Wait. Whoa. I met a new friend, and he is Kampf on. He plays on a DEF CON radio, and he plays progressive trance and stuff like that. Let's see if I can find him. And he has a channel somewhere where he plays music. I'm gonna push it. don't know. I don't know. Let's see, chaos. Chaos. Kampf. No, he's called Kampf. He's called Camp. Whoa. Losing my mic. I need one of those hangers, you know, where you put your mic thingy, or what do you call that? I should ask Alcantara about this. Yes, all the gears, man. All the gears. Kampf. Where is Kampf when you want him? Where is Kampf? Where is Kampf? Kampf. I know he's somewhere. He gave me. He might be on Discord. That's why. Okay, let's go on. Do. Yeah, let's see. It's here. Chi while it's charging. Yeah, no. Now I know it's cheat charging. Yeah. All right. Let's see. No. Oh, God, he wasn't there. Where is it? Is he at? Where is it? Is he at? Where do you get that one? Oh God, that's some good music. Yeah, it's some good music, man. Good music. Come, where are you? Ah, here you go. Come on. Somafy. Yeah, Somafy. Have you ever seen that shit? All right, cool. Cool. All right, let's see. Nerd show. Yeah. Here we go. Let's see. All right, cool. Let's see if we can go out. Yeah, and a side note for all of you guys who want to add keys, you know, I love you guys for adding keys and stuff like that. I don't know, let's see this one. No, this one. This is Kampf. I'm gonna switch over to listen to his stuff now, see if that's better. Alright, let's see. Pause Spotify for a while. See if that's better. Conf. Alright, conf. No, that's not what I want. I wanted this. Oh yeah. That's some good beats there. Oh yeah. Chill out, wave. Okay, cool. I like it. So big shout out to Kampf. Well, I would say Kampf. Kampf. He's been doing this for years, man. So yeah, good guy. One of the good guys. Yeah. Wow. I wonder if you guys can hear this music. I don't know. If that is possible. I wonder if that is possible. So if you guys, I wonder if Another thing. Have you all been buying your SAMs for Christmas or wishing that? With SAMs, I mean the specific secure access modules from HID that enables you to use a NARD and a little bit on Proxmark to decode some of the COS and iClass SE credentials out there. If you don't have it yet, I suggest that you start doing that, especially if you're a red teamer or a pen tester or a vendor person. I don't know if you have the money, otherwise you could actually buy a CP1000 instead, but that's not always the easiest. I'm gonna do this, turn that one off. You can still see me? Yeah, you can. Okay, so we have two problems. One, index is not an index, one referenced, and then we have data that we're sending in isn't aligned, so it fails. So even if we remove this part here, it will not work, or this part, it will not work. What is it for? Maybe the first step would be to get this to work. That 5, that's 15 more. Okay, so that's 15 more bytes. All right. Do that. That's 80. Okay, let's see if we can go in for 80. 80 minus 15 is 65. Minus 10. Yeah, okay, so it's 55 is equal, yeah. Got 80, and that is minus 10 for preamble, minus, yeah, 70, and minus 55 is equal 15. Okay, so it's a middle-sized. It's not long, like it is mentioned here. It's a... How long is it? How long is it? What is short extended? What is short extended? It's a long. I don't get this. CP1000 is $1,500. Ah, fuck yeah, man. It's expensive. Chocolate time! Swedish chocolate! If you never had it, home. Nope. Oh yeah. This is the shit. Good shit. Well, I got a gift from Gentle Kiwi, which actually uses Dime, and that is actually made by Moravo, and that tastes delicious. So it's chocolate time, huh? And my way of working is edit and build? Yep. Yeah. Welcome to the life of a developer. Sadly enough, it's a C project, so all those fancy breakpoints you have in, you know, the modern tools, like in Java or C#, you know, you sit there and develop and you get breakpoints and you can just test shit out. Now I'm bound to printf statements and, you know, trying figuring shit out the old hardcore way. But yeah. Cheap stuff, oh man. The CP1000 is insanely expensive. Really expensive. So, cheers everyone. Let's see if we can do some more coding here and figure out the two different problems we're having here. One is the off by 1, 2 for Electra is the new length, which would be 70 or 80/70. Before we had 55 and 110 lengths. That is no longer true, so we have 3. Printf is your friend. It still is, man. It still is. Printf is for shit. I mean, even if you can do breakpoints with, you know, debuggers and all that shit. But yeah, call me old-fashioned. A lot of beer for. The thing is, why people buy a CP1000 is, you know, this is because they work with it. Yeah, you'll work with it. I have to turn on this light, it didn't help. It was too dark in here. I have to do this, sorry. Yeah. This all started with me actually wanted to do, for you guys who didn't see this stream from the beginning, it was actually me. If I do an LF read on an unknown tag, I get this. And if you do data plot, it's a nice AM signal. So data raw AM. Alright, cool. Data print X. Alright, seems to be something repeating if you look at this kind of fast. And then you have data autocorrect. Window 4000, and then G to change things. And if you zoom out, this was my first thing, is to I wanted to figure out this, because this is the length between in the repeating pattern in the signal, basically. So with that meant, and if you have data detect clock or something new, oh god, set debug 0. Sorry about that. So that's clock 8. That was crappy. That's not good at all. It's kind of bad. So I actually modified, this is what I started out with. I was modifying the search with unknown signals. Okay, yeah, data raw. Now read. LF read. New signal, thank you. And I was filling here, so this is the automatic. There's no FSK clock. Let's go clock to see it's 32. It's a demod stream. And when you do that, you can do this. This is what I started with. And you can see how many samples it is. And one sample is with a clock means that 32 samples is 1 bit. And so you divide by 32 and by the clock value detected and by 8 bits to get bytes. And that you see there's a 8 bytes repeating pattern. 8 bytes is 4 blocks of T5577, which has 4 blocks in it per each block. So it's a way to try to detect, you know, and analyze unknown signals. NRC I added this as well, but it gives very much, it's very similar to ASK and usually gives you false positives. By the 16 clock, that's a very unusual clock, so I know by just looking at that one that this is incorrect. And then you see that PSK wasn't either. So that's where I started, and I wanted to see a repeating pattern. You know, I want to see the hex pattern that's repeating, and figuring out the minimum repeating pattern without repeating the same pattern within the demodulated string. In order to say, like, I think that the repeating pattern starts here. It was more of saying, I think the pattern starts at an offset. From that offset, it should be 3 blocks. That would help you with trying to decode unknown signals. So that was this beginning. And then that was the Electra thing that people was having problem with, and someone shared one of those signals, and if you look at that one, oh, okay, here you go. If you look at that one, it looks kind of nice, but when you try to search LF1 unknown, you remove it and doesn't decode. That leads us to is a 16-byte repeating pattern. Okay, cool. It kind of makes sense from, you know, if you look at it from here to there, about, you know. So with that knowledge that I want to do, that would have helped in these scenarios to start pointing out what you want to do. And that led me to doing the demod problem, where it takes the signal and it leads me to here where the parity fails, and then I was like, how about if I could set or call LFDM on this one with a binary string directly when I've done things, and, you know, try things out myself. It helps when you're trying to figure shit out with unknown tags. So this is what I call how to master the tools of a trade. And what what I mean is like this: if you're like a carpenter, you know what a hammer and screwdriver is, of course, but in the end, you need to craft your own tools, and you need to be able to wield that tool. So it's like two paths. You should be able to change or modify one of the softwares. You have to understand that software and the limitations, and then you should be able to modify that software in order to improve it to do what you want to do. And that's what I'm trying to do right now, a little bit for me. And usually that, when I look at it like that, it benefits the community in that sense. And I want you to have that mindset of you who listen to this and you think like, oh yeah, I can clone something, or I can use the Flipper Zero. Well, it's very simple to use Flipper Zero because you don't have to think. But you never master your own tools. You don't master the tools of trade. You master one device, but if you're not able to decode and change and update the Flipper Zero source code and run that, you are limited. And you should always try to improve those limitations of yourself. Cheers. We use other things. Speaking about that TED Park, it's we also use something like covert scans and CCP checker, because all this C code is really prone to memory leaks and bugs and wrong stuff, and it really picks up all that. So we have static analyzing of the source code, and that really brought the level of quality in the project. So before, the client could just break and you never knew what was going on, and it didn't go on. We still don't have that same level on the device side, and we're also suffering from, we can't make unit tests with a device like a Proxmox can say like, yeah, let's make sure that everything works like it should do. We don't have that, and that is, it is what it is. But it's really, you need to have that in mind when you do things. And some of the developers out there is very good, like this WH2019-06, who added the prolonged LF samples, where we now can collect like over 1 million samples. Bringing a new way. This is a very old hardware, speaking of which, this is like from 2002 or something like that, MCU. So yeah, I'm still surprised that we can run this project, and you can use your device from 2010, and you can compile this project and flash it onto it, and you can use the modern stuff on that old device. That's kind of amazing. But that doesn't fit into the gadget con, you have to collect them all. Yeah, you should. You need to do it. You should be able to compile and not be dependent on things. Many professional people, or Red Team and so on, them knows how to do that, so that's good for them. But when they want to push the limits or push things forward, they have to do more, basically. Also have to remember, CP1000 and stuff like that, you don't buy it personally, well, if not like me, but I have one, but I have no use of it. But you do it because the company pays it for you. You feel me? So you don't do it. That would be too expensive. But if a company buys for gear, then this is a different story. And if you just want to clone something, buy a modern cloner instead. It's better, But if you're curious, want to learn, then I don't know, you can start with everything. Everything is like a stepping stone. Chameleon Ultra is nice and smooth and small. I don't use it. It's not because it's not so nice and smooth and cool device. It's just that when I analyze things and try to do things, I have no use of it. It doesn't fulfill that, the need for me. If I would put it on a keychain and walk around and try to open doors and the way I want to do it, that would be it. But I don't. So I don't know. But it's also good to learn. It has potential, but it's severely lacking development and community developers. Well, same thing with Proxmox. The developer comes in and want to do things, and then it's gone. So it's tough. That's the big advantage with the Flipper people, though. They have, what is it, like 6 developers or something like that, paid, full-time paid people. Improving the stuff, that amount of resources, a lot of things will be changed. Have you played Halo, guys? Have you done that? Tactical block picking. So what do you all work with? Do you work with pen testing, or do you just have a hobby? Or what is it? Mm. Message requests. Rabbit. Entering the rabbit hole. Yeah, you all do that. It all keeps on falling. What is my music? Okay, something else. Give me a suggestion of some other Progressive trance music. Repairing video games. Wow. The arcade ones? What do you think about that madness? What was that? Oh, the guy was also accused of cheating in Donkey Kong, and it's like Pac-Man, or what is it? I don't know. That's kind of awesome, though. What was his name? Billy. Billy Mitchell. It's a bizarre story. Really bizarre. It's a bizarre story, man. Yeah. Do you still have those arcades at home? Do 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 do. Na 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 na. Do 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 do. DJ Sammy. Ah, group. Above and beyond. Above and beyond. Here we go. Doot. Advent of code. Isn't that now? Advent of code. Let's see. Advent of code 2023. It is. Advent of code. Cool. Mm-hmm. Do. Okay. Advent of code. I'm not going into that. There's another rabbit hole looking at other people. Coding is interesting sometimes. Always getting stuck at things. SK Telecom T1 Faker. I need something to distract my mind. What is good for that? Half-Life? No, it takes too long time. What distracts it? Good cold beers, yeah. Cheers. CADWorks? Damn. Old machines rocks? No, it's just pure lead, man. Pure lead. Not that it's gonna happen for you for such small exposure, but if you touch lead every day, you're gonna have a problem. Lead is nasty. I don't know why we made lead in petrol though. That's an interesting choice to lubricant engines with. Feels like we could have chosen a different substance or grundämne. I think if you go to Vegas, you see, the only thing is the future is not arcade games, but but slot machines. I think slot machines is the future. If you look at Vegas, at least, that's what people do. Yeah, okay. I need to distract my mind. Give me a suggestion for something. Mm-hmm. Mm-hmm. Do, 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 do. Mm-hmm. Robin Bradshaw. Bradshaw. Why did I know that name? Premature combustion. Okay. And for Ab. I thought I recognized that name. There you go. How you do, huh? Japanese fireworks video. Okay, let's go for that. Let's go for that. Okay. Oh man. Japanese giant firework. Right, let's see. Right, let's see. Let's see. I know. Holy moly! That's a gigantic. Jesus fucking A! Holy fuck, I need to go to Japan. I mean, I want to watch that live. I watched some fireworks in Thailand some weeks ago. That was fucking amazing. Wow. If Alcantara is still on, it's like, I want to go there and watch those fireworks, man. Okay, let's jump. Wow. Jon Shakudama. What does that mean? Jon Shakudama. Hondoroso. Manually doing that? Wow. Holy crappy. Looks like hand grenades. Shakudama. Damn, I want to go to Japan and see this. They seem to have the right priorities. 420 kilos. Six. Jesus Christ. Have you ever seen that? Have you seen that live? That's almost half a ton of gunpowder, of black powder. Jesus. Wow. Wow. I want to go there. I don't know what to say, man. It's not one, I've had 2 launch pads. You see that? Jesus Christ. 800 meters. I mean, just handling it, just like, boom. Static electricity. Nope, we don't care. Okay, let's see. Let's see. Wow. Wow. Oh man, that's just too amazing. I don't know what to say. I know I'm not capturing the sound of this, but wow. Wow. Oh, fuck. Yeah, exactly. Wow. That's a failure. There's 2 of them. Wow, look at that. Look at that. That's it. That's it. Holy fuck. Hey, Franco. Thanks, man. That was amazing, that fireworks. That was still amazing. That was a good sidetrack. I can tell you something else that I do like. I have a secret confession to make. I do watch esports, and my favorite watch is actually 2 of them. It's StarCraft 2, and it is League of Legends, LOL, and also this World Championship just lately, and one of my long-lasting teams that I've been vouching for. Rather one play that I really like. I like Faker. I don't know if you know about LOL. It's a team play, so it's like two teams meet. So it's 5 players in each team. A normal game is 20 to 30 minutes long. And that guy has been there for 10 years. He's still on top of his game. And it's amazing to watch it. So I tend to watch League of Legends too much. That's my secret confession. What is your secret confession? Max Mixer Workshop. That was kind of awesome. I saw some of it on Twitter, to be honest. That's kind of funny. What do you think about X or Twitter nowadays? Is it, same fun or is it less fun? I think the whole IT community has or the InfoSec community has been spread out. I don't know. Except one champion. Was that in final minutes? Someone did something like that, wasn't it? Like the last 40 minutes, 40 seconds. I was like, championships. No, not Dart. Excel. Finals. Yeah. Australia. It was an Australian guy who won it. 4 figures. Man. So what do we do? on Excel World Championships. I mean, I don't get it. Grok can be entertaining. I mean, I used Flashback and I've never been to other ones. Do you guys go to like the dark web or stuff like that? Or what kind of forums? I mean, Discord has great places to, you know, hang out and, you know, just lurk. But I don't know. I don't know. What do you do? What do you do? Do 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 do. Okay. Alright, back to this one again. Two problems. First of all, it's not long anymore. Now we have 70 and 55, so that sucks. How about we do this? Size is a size T. Running around with a parade. What is the normal length? What is the normal length? I'm using Visual Studio, yeah, for sure. Yeah, Visual Studio Code. Simple and free. So I use, on this computer, I use VSL. I run it Windows Subsystem Linux. And then, yeah, so Visual Studio Code is very simple in that sense. You get a good editor for, or IDE. Maybe one of these days I should learn how to enable debugging. Maybe it works, not works, I don't know. What I'm working on, Mr. Iceman, you know, Iceman is good enough, you don't have to. Very polite of you, but you don't have to. I'm working with two things actually. Let me do that again. Clear. I started out with looking in something, you know, for unknown tags. So if I load an unknown tag, right, let's load a known tag first. That's because of, you know, if you do left search, -1 means that it uses the data samples that are loaded previously, and instead of asking the tag, when it finds it finds it like this. Otherwise you're gonna add also something called the U for unknown, but since it's found, and then you have to do continuous, and it tries to decode things for you. So if I load an unknown tag, where's man? No, this one. So if I do a left search here, this is what happens. And I don't know, it's not enough for me. So if you add the unknown thing, I added NRS set demodulation, but it's a little bit annoying. So here's a thing, I changed this. This is what I'm working on. So it detects if there's an FSK clock, you know, with modulation, and if it's not detected, it just tries to skip it and goes on. And if it finds one, it decodes it. Now after that, it gives you this. This is, you know, for an unknown tag, which is kind of interesting. So what is autocorrelations? Well, we have a, if I load this tag again, and I show you the plot window. So this is how the signal looks like. It's a very decent signal, it's not with it, it's sniffed. And if I do data raw AM, because that's what I know it is, it finds and decodes it pretty well. And I modified detect clock a little bit, so it will find the ASK clock, which is good. Now, if you do this, you know, manually look at this, you can see that it's a repeating pattern. But we use, when you do it machine-wise, you do something called autocorrelations to detect if there's a repetitive possible correlation of the data. In this sense, it says that 2174 samples, there's a possible correlations. And if you add the G parameter, it modifies the data plot window to show you what it's finding. So this is mathematically, it tries to see things. So if you go from there, from the peaks to the next peak, it's about 2000. Yeah, well, if you look there, it says 2074. So that's the distance. So as a pattern that's repeating, that is 2174 samples. Now, what does that mean? It doesn't mean anything at all, because one sample is you need to have it in relations to, you know, the frequency where you're doing it, and the field clock that's ticking on. So if you have a clock, let's go down here, modulate control, this is the clock. let's give me a clock. Here's a clock. This one here's a clock. So you need to know how this relates in order to demodulate it. So if we have the samples and we know the clock, we can divide it. So that's what I added to this one. And now I can't do it because I have to reload it. Yep. So, and if I go here, you see that this is the samples. So if I divide it by the clock, because 32 samples is 1 bit. That's the bit length in this modulation. So in order to get 8 bits, I have to divide that also with 8. So from that sample set from autocorrelations, we can determine that there's an 8 bytes of repeating pattern in this block of signal we're looking at. And that would mean 2 blocks of T5577. What I was wanting to see was data raw am, data print x. So if you take this, for instance, yeah, let's do this. I go here, under new, and I'll do this. We can look at this data here, like, oh wait, I see something repeating here. Why is it? What? Here you go. Let's see. There's one, and here's another 22, and here's another 22. It said, what did it say? It said, not when I see. Because the clock is 16, and that's a very uncommon clock, so that's an indication that it's a false positive. And it says 8 bytes repeating. So let's go back here. That's a little bit more than 8 bytes. And then when I look at this, oh wait. I see that actually the repeating pattern is this much. Cool. So from here it's 1, 2, 3, 4. This is the 2 different blocks that's, you know, would be needed if you want to make a clone out of it. Nothing of this tells you what the start or where the preamble is to use in order to detect where the signal actually starts, but this is the raw data that's repeating. Now I wanted to know, given this, you know, this is what you demodulated, I want to know this. This is the minimum pattern length that exists in this big string of repeating data. And I don't want this because this fits as well as this fits into the length, but that would be wrong. So that was leading me into finding the highest repeating value for things. And that was something then that led me into the Electra, the Romanian Electra tags that was discussed a little bit on the Discord, which is, let's see if I can load one in, and dumps elect lf. So you, whoops, can't free. So you load something in, and you look at this data there. All right. So you have a data window there. You see it's a nice signal, it's not with it. But if I do search -1, nothing happens. You see something wrong, it doesn't add up here, so it didn't find anything. When you go for unknown before, you wouldn't have gotten this part, and you wouldn't have gone this. It says it's a 16-byte repeating pattern, the clock. So that leads us into, here's that, data print x, and now we know that the repeating bytes is 16 bytes for blocks. And well, you can see the 5s here, that's kind of easy to see the repeating pattern of that sounds. It would be nice just extract saying here is a repeating pattern. It doesn't help you doing things, but with that said, I know that Electra is based on the EM4010, the EM4100, 4100. which has a header and then blocks of 5 bytes where the last byte is a parity byte. So this is parity bytes. And this here, that's a row parity, and this is column parity, meaning that this one goes, this one, and this one, and this one goes to those values there, and this here is a stop bit. So it looks like that. Now, given this, you go like, huh, well, that's interesting. And if you have a binary here and it doesn't work, you would do lf em4100x demod. And you go nothing. When you go data set debug a little bit more, because you want to see why it fails, it says parity failed. And you go like, huh, how about, this is where I started this stream, is like, how about I can actually just add binary string to test things out, you know? If I convert that hex value into binary, which I did up here, and you would come down to this value, and I want to do this, and here you see it fails. And this is where I am at and why it is. And there's like 2 different kinds of bugs. One is when you demodulate this here, this signal up here, the Electra demodulation. Let's go back in here again and do this. Let's add things up. Let's see. So here's 0 on, that's the header. That's not the header. You have to go a little bit more wider in order to see this. So here's the one, here's a header. That's the header, and then you go repeating pattern. Oop. So here's line them, you align them all up. Now you can see it by its, you know, marking like this, and it's 128 bytes. Problem is, if you look at this, and what we try to look here, is that it contains this sledge of data. So if you divide this data, we take off a header here. That's the first one that you can ignore, that's just there for fun. And the schematic said starts with 4 ones heads. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it was 5s. And you see when I do this, this is what I've been doing up here. And then this is parity byte that is defined here. All right. And this one was the column parity. Now, if you look at this here, there's an edge here for this electric. And that is, I will do this first. 5, 5, 5, 5, 5. It's a sledge of things, and you know, that shouldn't be there, which is annoying. And then if you look more at this data here, I'm going to take it away because it's all up here, is that in the normal EM41, it's only 0, 1, 2, 3, 4, 10 or 11 rows of data here. It's 11, there's 0 to 9, that's 10, plus 1 is 11. So that's this, but this data we took from electric has some extra bytes here, plus this. And with that, I was looking into why this decoding of it did not handle it correctly. And that's when we found out. I tried to add this binary thing. So I got a this demo doesn't work, but is this one? No, that's 2. That's wrong still. Yeah. So I need to do that. That's what I'm doing at. This is what I'm looking at. Trying to figure out why. And it's not because I want to solve electric. It's like uninteresting in that sense. It's more like I want my tool to be as helpful as possible when I'm analyzing unknown stuff. Does it make sense to you all? No, I'm thinking. Because this is not, I mean, I can see it repeating, stuff like that. Yes, everybody can do that by seeing that and line it up. But as much if a client could actually just give it from the beginning, I don't have to guess when you stress around and you assume things, but you can actually tell you it. So yeah, that's what I'm trying to do. Did that make sense? VI. Wow. Oh man, I didn't use VI for a long time. Use Vim as well. You want me to annoy you most? I still do Nano instead. I like that. Still the same thing. VI, man. No, I use Pico or Nano. Nano has been one of them I use nowadays. When I'm in the terminal. Otherwise, I'm in Visual Studio Code. Right. Alright, let's get going. Do 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 do. Mm-hmm. All right. Bugs. All right. How to identify this shit. Mm-hmm. Tiesto. Tiesto. All right. Mm-hmm. All right, let's see. What can we do about this? All right. $255, yeah, should be right. No, it's crap. EMV things, oh man. You choose a hard subject, man. So much levels. So you have above the ISO standard communication protocols you have is another ISO standard 7816 where you use APUs. And then you add crypto and customized applications, and yeah, EMV is that's the advanced class, man. Sorry about that. Dang, it's moving. Well, you know, yeah, like I said before, you know, you have to tweak the tools in the way you want to make it work yourself. Location. Location. No, that's not location. What the fuck? Okay. Spelling. Okay. Well, that doesn't look like. Anyway, so. Well. Quit bits. What more do we have here? How much would bit size? Alright, cool. Hold on. X, size. Let's see if it's. If it's less than this. There's a big chance that it's not repeating, right? Okay. Yeah. This one still hacks. All right. Parity. we don't need to do that here. I don't need to do that here, thank you. Oh, don't do it. No, that's perfect. 70, yes, so 70 is break. Nope. Nasty hack again. Mm-hmm. Mm-hmm. All right, cool. Let's see. All right, that's long. That's not long. Not long. Okay, då är det speed length. Klicka med 128. Oh no. Pre-configured workspace to open. You just run code with a dot and it opens it inside of it when you git clone the repo. Or if you mean a repo that you don't have to compile, you can just download the proc space environment on Windows. Okay, load traces. LF80. That worked. That's good. Dumps L. That failed, of course. And now nope, not that one. 1000. Okay, 4440. Like this, right? Yeah, like this. Bin. Okay, that works. That's cool. That should work, of course. This one. Should work. This is 79. That's 80. Oh, should be 80 white. Maybe. Let's see. No. Where's your fail? Okay. What now? Yeah. Yeah, for sure. Mhm. Yeah. Thank you. Yes, do let's do a little code, and it starts up, and there you go. Yeah, I don't know. Always thought Visual Studio Code is a simpler version of it, but I focus on so much different things than a normal Visual Studio. You could start debugging. I don't think we have those, do we? On task, yeah, here. Client debug. Make. We have those. Hmm. Hmm. Yeah, they all have different dependence and stuff like that. Hmm. Mm-hmm. Do 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 do. La 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 la. Do 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 do. Okay. Okay. I wonder, did you do this? Okay, okay. Wait. Okay, so it's not where. Bum bum. There goes printf. Fuck yeah. Yeah, it does. Yeah, there goes printf. Yeah. Oh, whatever. If you want to start coding and you see this file, lfdemo.c, it's one of those nasty files. It runs on both on device side and client side. So it's not that simple. Yes, and you know, if you do stupid mistakes, you don't do that. There you go. Right, great, 79. Great. Okay, cool. So at least it's adapted. Alright, cool. We don't have to go more. If it's detected, rusting words. Reason why this pattern should work is because that 5 bytes, 5 bits, 5 bits, this should break that. You know, this should break the normal parity check, so that should be enough to identify. That is special, that would be identification. It's a special kind of things. Normal. Okay. So, question is here, this extra things for this unknown Electra is, or the unknown Electra, is this a column parity word? Row, or is it data? And is this a column? Is this column parity? Things that you don't know if you do this. So what we have here, All right, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. No. 3, 4, 5. Nope. 2, 3, 4. Nope, that's not it. There's no column parity, at least. That's not it. But it's row parity. Okay, cool. Because then this is not a stop bit on this one. It happens to this. I think it follows this when it has extra data there. Okay, cool. Wide chirp. Short, extended, valid, long. Okay. All right, let's see. What is valid long? What is valid long? Yes. What is valid long? What is valid long? Okay, let's go for okay. 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 Fob. No. Clamshell. All right. Fob. Fin. No. It's a plot. Oh, that's a crappy signal. Wow. So you wonder what is a crappy signal? This. You see, this is spillover data from a carrier signal crapping out on the signal quite much, actually. Ugh. I wonder if we can do anything with that a little bit. Let's see, what is it then? 27. Look here. Okay, so we're around minus 68 to 58, 60. 72, okay. 70, down, 70. Nope, let's not do that again. Not that. Let's do, can we normalize one? Can we normalize this? No, decimate, no. No. Oh, nice. Can we do data norm? Didn't work much. PF is found. Oh, don't have IRR? Yeah, I do. Okay, let's go for that one. IRR. Okay. Well, it goes well. I can load it again. Thank you. Not very well. Parity checks fail. Okay, let's see. Or is it that this one fails at? 6, 8, 9. Okay, cool. 3, 6, 9. Ah, okay. Yeah, that's nothing else. All right. Correct. Cool. Cool. That's the last one that falls out. Okay. No, it's okay actually, because it's not. Well, it's okay because that should be a stop it. And 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10, right? Yeah. So, okay. Is this one? Okay. 3, 4. That's okay. 3, 4. 2, 4, 5, 6. I don't get it. It's okay. Okay. I don't get it. I don't get it. Why is this one not working? With 64. 65, okay, cool. So 64. Nine. 66. 10, 20, 30, 40, 50, 55. $63. Okay, well, that makes sense. Well, this one says it's 64. Okay. All right. Yeah, I think I'm gonna stop doing things tonight. It just doesn't seem to add up. Like this. Hard coded values. Yeah. I'm done. I'm done. I'm done. I'm done. I'm done. This is nasty signal. All right. I'm done. I will try to stream some more during Christmas, but whatever. Just because I think it's boring to sit alone sometimes. With that said, and if I don't hear about you or see you or anything like that, have a good and happy holidays. And thank you for everything and tuning into this. Take care. And El Contaro, go out walking with me, man. You're welcome, Robin, or Bradshaw, or N for Rab. You've been around for a while, man. Have a happy one.